Hi there. Today I want to talk about DEFT, Digital Evidence and Forensics Toolkit. DEFT has a bunch of different utilities, and to try and show a few of them off, I'm going to work with the Washer E01 image that we worked with earlier in the semester. So the first thing that we need to do is mount that image so that we can work with it. So to do that, the first thing that we should look at, just to make sure that we're working with the right image, is run the EWF info command on the image. This tells us all the same information we would see if we were working with FTK Imager or any of the other FTK products, such as case number, file format, and most important of all, the MD5 hash. So when we're working with this, we know that so that we can hash the image to make sure that it's remaining the same as we're working with it. So to actually work with it, we need to mount it. So let's go through how we would mount this in DEFT. So we need to issue the xmount command, specifying the EWF format, then the image file, then the mount point. So now when we go over to media/image, we can see two files, washer.dd and washer.info. Washer.info contains the same information that was provided to us by EWF info, except in a plain text file. So we can, just quick to make sure that it was mounted correct, we can run an MD5 sum on washer.dd. And you can see that those two MD5s are the same. So we know that our file hasn't been corrupted. So in order to actually work with that image, we need to mount it again. There's two layers of images that you have to mount. And this one's a little more difficult. So we need to issue an fdisk L to see some more information about that image. So it's important that when we mount it, we need to consider that there's an offset between the start and the actual start of the image and the start of the actual data. So in order to determine the offset that we need to mount it with, we need to take 63 and multiply it by 512, because the program that mounts the image requires an offset in bytes, and this provides us an offset in sectors. So let's continue to mount that then. Mount T for type, and then we NTFS, options read only since we don't want to modify anything, offset 32,256, washer D and media DD. We can CD to media DD, and we can see all the files that are in that image now. So we can run tools on that directory to retrieve data, or we can just browse through it, like with a file manager or something. Just like you see in normal Windows with all the users and so forth. So now that we've completed that, I'd like to move on to password cracking, which is essentially required if they're utilizing any form of encryption. So in order to get started with that, we need to cd to the Windows directory, and then the System32 directory, and the config directory. And in that, it contains the SAM and the security file, both of which are required, or the SAM and the system file, both of which are required to retrieve the password hashes. So in order to so the SAM file is actually encrypted with a key stored in the system file. So in order to retrieve that key, we need to run the bkhive command on the system file, and then output the key that's contained in it to just a temporary file, that's just for our use. So then we need to run the samdump2 command, specifying that the encrypted file is SAM, and the temp and that the key file is stored in temp/key.txt. Then we want to redirect the output to our home directory, which is root, and then the file hashes. Oh, I messed that up. So now when we go back to our home directory, which is in root, we can cat hashes, and we see that all the password hashes are stored right there. And then we can just we can run the John program, which is a password cracker, specifying the hashes file as a parameter. And I think I might have cracked these earlier, so they're not going to show you the actual passwords. But when I cracked it before, it showed you that administrator was immediately meth, which we had also determined in FTK. So after that, we can look at some data carving functionality, which we can look at, and there's a bunch of different tools in DEFT to do that, but the one that I've liked the most so far is foremost. All you have to do is specify say foremost, then specify your image with the path to it, with the I, and then run it. So it takes a while, and it finds all of the files that might have been deleted in the image that were still recorded, and it outputs it to the root/output directory. So we can cd into output and run an ls to show everything, and we can see that all the files that were found are sorted by their respective extensions. So I can go in, well, it's actually easier to go in and browse to it in a file manager. So we can see all these images were recovered, and like these are more images, a PDF, which is encrypted, and so on and so forth. The final thing that I want to do is just look at how we would just generically find things in the image. So we need to cd back to media dd, and then we can just run find dot specifying the current directory, the name argument, and then specify star.doc or whatever extension we want, such as star.png and so forth. We can run that, and it'll show us all the documents that match that rule in our image. So this has been some of the core functionality of DEFT. Many of things such as the find command are just basic Linux commands, but foremost, samdump, and bkhive are very specific to this, and the core of starting working with any forensics images obtained by software such as FTK. There's many other tools that are interesting, but there's simply not time to cover all of them. Thank you for watching.